Hello? Oh, there we are. Okay, sorry about that. Welcome on in, everybody. Pro streamer technical difficulties. Apparently, double mic muted. Fun. Yeah, you can hear me now. There we go, Barry Printer. Thanks a lot. Welcome back in, everybody, to another exciting night here in the Dragon's Den. Uh, I believe, have all the parts in, or I can borrow a part to get the toolhead back together for the Optimus P1. Now I'm going to have to do a couple of things, and we'll be rebuilding this again later on potentially. But we have everything we need to get a toolhead going and get it back down to Echovate. And then what I'll do is when some other things come in, which I'll talk about here in a minute, I may go down and do a swap out. Welcome on in, Eagle the Dragon. How are you doing tonight? Hopefully you're doing well. I do have some coffee with me tonight, finishing up some Black Rifle, and then I've got my Dunkin' that Mrs. Dragon brought me earlier. So, in fact, I'll switch over to the Dunkin' because that one's full caffeine. So, hope everybody's doing well this evening. Having a good week so far. It's April 1st. I don't like to do a bunch of crazy, clickbaity, weird stuff on April 1st. I just want to get into things, and there's enough craziness and confusion going around on April 1st. I don't want to add to it anymore. Um, but I hope everybody's doing well. So tonight, by the end of the night, the plan is to have all of this assembled into a full and final tool head. Second. Ah, 1 second, folks. Forcing a filament run out slash roll over into the next spool. Yeah, so this is the plan, is to take all of this and put it together into a new tool head. So a couple of things that have happened since the last stream and off stream. We've got the 50-watt heater cartridge that came with the printer. We're going to go ahead and use this because I have an unknown cartridge, meaning it's not marked, and I don't know if it's a 12 or 24 volt. Hey, Thunder Keys, how's it going? The other one that I have, I know is a 40 volt, or excuse me, 40 watt, and this is a 24 volt 50 watt. So we'll go with this one, and I'm going to order some more 65 watters for the printer. I have also done up both a cartridge style, this is an HTC 100 thermistor, and a bead style. And here's why. The first setup that we got, this is a E3D nickel-plated copper block. Apparently uses a beaded thermistor, means standard thermistor. We've got a titanium all-metal heat break. It does take a short piece of PTFE at the very top there, if it'll focus. Hey, focus. Gus, yeah, I'll take a short little length of PTFE there, but nothing big. And then we'll put the 50-watt heater in here. We have a 0.6 Batis hardened steel volcano nozzle. Okay, so we're going to use the bead thermistor, this setup, and the 50 watt. Then I'm going to order some more parts, and I've got another plated copper nozzle, and it's definitely not all aluminum just by the weight of it. But this one will accept a cartridge style thermistor, and thank you, buddy. This one will accept a cartridge style thermistor on this side, heater on this side, and I've got a 1 millimeter volcano nozzle. It's a vanadium nozzle from, yeah, Slice. I believe it's a Slice Works. I bought it from KB3D. They had them on closeout. So I got a 1.0 nozzle coming, and the plan it's that's what it is. It's a Bondtech CHT vanadium nozzle coming that we're going to throw in here. It's a 1.0 with a 65-watt heater, and I've got a PT1000 thermistor that we can use. However, I'm not sure if we can use this with the standard board. So this is kind of like the next step. I could set all this up using the cartridge heater, but I want to get the PT1000 because eventually I want to be able to go over 300C for reasons. Okay. And the issue that I have there is the board itself is an NKS Gen V1.4 board. It's an 8-bit board, and I don't have access to the firmware. I've reached out to the company. I haven't got a response from them. They're more than willing to sell me stuff, apparently. It's may come in this week or next. But I can't get any information on the printer or the Marlin firmware. It does use a custom Marlin firmware with a custom graphics display and stuff. If I could at least get their Marlin settings, I could reverse engineer it potentially. What would be great is if they just give me their Marlin settings and we can go through and actually clipperize this. If we can't get their settings, then we may just clipperize this thing to be able to get up to higher temps and be able to use a PT1000 thermistor. Because even if I put in another thermistor, there's hard-coded limits in Marlin for temps. So some people have said that they've put higher heaters in there and they were able to get a custom firmware from the company, which is in Sweden, to be able to go up to the higher temps that they now have headroom. So yeah, so I've been looking at this and how to get things put together. And if I remember my order of operations right, I really need to start by putting the motor on the back. And I will tell you what I did was I went through with a pick and tried to pick out all of the gunk that was in this drive gear. And I think I got it all out. I do have a new drive gear. I ordered 2 of these drive gears. They are, they do have a set screw on them. So I'll be able to pop this one off, put the new one on, provided I can get the set screw out. Hey, Pez, how's it going? Uh-oh, well, fixing your AMS. What's wrong with your AMS? I know one of my AMSs has some squeakiness, like more squeakiness than normal going on it. There is what appears to be, I don't know if that is a like filament guide area or if that's just where the filament has been wearing through this. That's why I wanted to get new ones. But you can see there's a definitive line here where the filament has been going through. And I've been debating which way I want to run the wires on this. they were going like this and getting routed through the side, but then that leads to some wonkiness with some of the other wiring in here that I'm just not happy with. So I'd prefer to route the wires some other way, and I don't think we're going to be able to. So we'll line this up. We can do the two bottom um, bolts because that's not going to be an issue. We have to get at least one of these bolts in. Um, there is a cutout here, but it's not enough to be able to pull that bolt out and get a nut in there. So we have to at least get the bottom two bolts in. I'm going with the smallest two bolts we have. And I'm going in at an angle. I should have used my ball end screwdriver. So let me grab that. And you may have heard me mention before that the JST connectors I had on hand did not fit. So I now have a set of, size are these, 2.5 millimeter pitch JST SM male and female connectors. So, yay. So we've got the lower two screws here on our drive gear. Now what we need to do is get our extruder going. And here's what we're going to do. I've ordered two of these extruders from FebTech because this one has seen better days. Like that is a hole right through the side of it. Very, very similar, right? This is the Feb top. This is the one that came on the Tech X Pro. They're the exact same thing with a little bit of difference in the push down mechanism. What I'm going to do, and I hope he's not watching, but if he is, it doesn't matter. I'm going to borrow this extruder and use it to rebuild this tool head. It's the same exact extruder. I've got two of this side. So the the Tech X Pro is a dual nozzle, dual extruder system. Not an IDEX, but it is a dual nozzle system. Think like the new H2D. So it doesn't have an independent X axes. It does have a independent tool head. And sorry, I just lost my train of thought there. The it has an extruder that faces the left and one that faces the right. So I'm just grabbing the right facing one because that's the style that was on here. And we'll take this, we'll line it up on the gear and push down, line it up. I'm going to make sure that it does line up with my filament hole, which it does. So it's just a secondary verification. Now, this side here takes a a countersunk screw, which is staying over here on this one. So I'm going to just go grab one out of my stash. They had a standard cap head screw, which, nah, we'll go grab a countersunk screw, flathead screw, countersunk screw, whatever they want to call them. It'll be silver, not black, but that's okay. It'll be covered up anyhow. Oh, sorry. Allergies. It is like everything, well, is like greenish yellow outside. It is horrendous. Now, hopefully I didn't just break that piece. I did not. That's good. Size we're gonna get here. Hey, Rob C, how's it going? Hope you are doing well. I was gonna say we might get lucky and might actually be able to use a, nope, probably not, because where this is going directly on the face, this has to go through this thick metal plate. So I'm not going to be able to use that one. Do I have? Nope. I'm going to have to at least go one size up. And when I do that, I'm not going to have a black countersunk that'll fit. So, nope. Can't even go one size. I'm going to have to go at least two sizes up. See if we have to go this far. Yeah, so I hope you're doing well today on this April Fool's Day. I started off by saying I don't partake in the April Fool's tomfoolery stuff, so you're not going to hear a clickbaity title or anything like that from me. You know, I'll leave that up to others to do. All right, no rubbish. And I was able to get a blackened screw, so yay. Keep the aesthetics going. So we've got this side on, got a spring and our lever. We're just going to set the spring, goes over the little lever peg. And then this sits in a little recessed cup here, right? That'll sit down in the recessed cup. And then we'll just kind of press and hold everything in place to get this other screw in, which should not be one of those either. It's going to be a longer screw. Let me, oh, what do we want to do? Probably, let's look at an 18. That looks about rightish. Dang. I'm getting good at that. We'll get that in place. We'll set that down there. Kind of give this a push. Let things line up. Hold that down and start getting this into the motor. Okay. Now you want to make sure that you get flush here and that there's no ability for this to walk forward, but you still want the ability to work your mechanism without undue tension. So now we've got what should be a working filament path. Next up, we need to get our block inserted. Hey Chewy, how's it going? We are putting the tool head together on the FebTop machine. So this screw you can't take out. It's a captive screw. It's used to, it's basically the set screw that holds the um, heat break into place. And we're going to need to slide this in here and basically drop it down. So we're just setting it up like that. You'll notice that that screw head drops right in place, and then these screws are going to go in. And it's interesting because these are M3 screws, but they're not catching, they're actually countersinking, which is kind of weird, but it holds very securely. And I haven't quite figured out, it's just got to be the like the knurling on the side of the screw head that interfaces with the hole that'll hold it in place. Really a weird design, but it works. And I'm going to yell at myself because I've done this 2 or 3 times. This is very much an order of operation issue. But you're seeing me take this back out, and there's a reason why. Okay. Pull that back out, and it's this fan. So I printed these standoffs, right? I just catted these up real fast, kind of figured out the dimensions and stuff, and didn't even CAD these up. I just did these. They're a cylinder with another cylinder. Did this in the slicer itself. I just figured out using my reamers how big these 4 holes are in this fan shroud holder, and said, okay, they're this size, and I need a 3mm hole in the middle that I can then thread into. What we have to do, because they're standoffs from the back, is we have to basically get this lined up and get all 4 of those little standoffs through. Line up, always one. There we go. Push that fan all the way forward, then take our heat sink and, oh, please tell me I can get this in there. Do not make a grown man cry on stream. Ah, it just barely does not. Come on now. Think through it, Luke. Need to do that, slide that through. I think I see what I can do. Tighten the set screw in. You don't need the set screw out at this point. Tighten the set screw in. That should give you enough room. Enough wiggle. There we go. Looky there. So if you tighten the set screw in, you get enough room that you can slide your heat sink through and drop it in place. Now with that held in place, you can add your other 2 screws again to lock the heat sink in place. Yeah, so Chewy, this is the tool head for the Optimus P1 printer, which is down at Echovate. And I've been working to get this back up and running. We're going to get it running. We have the electronics, and we'll see that all the electronics are working later today at the end of the stream. But, okay, so we're going to crank down on those. And now that heat block is in place. Now what's going to happen is we can just push this fan back all the way. on those standoffs until it's right up against the front. Fan still moves freely. Actually going to move freely because it now has the ability to pull in air through 3 of the sides, right? Where before it had a spacer plate here. And I know why they did it. You can see where I was trying to thread the fan in here. And then you see a couple of pieces of VHB tape. I'm going to VHB tape the 50/20 fan to the front, which would also give me the ability to get a screwdriver in here and pry it up if I need to remove it. But that is going to keep the pressure on this fan so it doesn't sit there and just rattle. But unfortunately, even though, I'm sorry, this is a 40/20, the holes don't line up. So that's the part that sucks. The holes don't line up. So now that we have that in place and everything's in place, we would be able to put in our heat brake. Now we've got to unscrew that set screw. Once again, it's captive. It's not going to fall out. So we can pull it all the way out. We can take a look, and yep, everything's going to fit in just nicely. Okay. Now, before we do that, we need to get our thermistor and hot end in here because they go in from the top. So if we put this in and we've already got we need to put our heaters in, we're going to have fun. So we need our thermal paste. And yeah, I'm going to wind up building basically 2 different hot ends for this. And the nice thing about that is once I do the second hot end, it's undo the heater and the thermistor wire, undo this set screw, and I can pull one hot end out, put the other one in, and not have to tear apart the whole thing until I decide to replace the extruder, which I should be able to take everything off the extruder and replace it without taking everything else off the front. And the reason I say replace the extruder, I've got so I've got 2 of the plastic extruders coming. I also have a all metal version from Funser that looks like it has left New York and it should be here by the weekend. Now, the items that I purchased from FebTop, which was 2 of these plastic right-hand extruder mechanisms, 2 gears, and something else. I can't remember what the other thing is. They appear to have hit New York and cleared customs the same day, but I'm getting no due date to my house. So I'm hoping that they're picked up by USPS at the same time. We'll see. But we're going to go ahead and don a glove, I believe. If I can get to my gloves. Get to my gloves, my daughter. Oy. Might be the last one in this box. It is. I like to use gloves for this, or at the very, very minimum, you'll want to clip off a finger and then put it on just a finger. And that way you might get a couple of fingers out of it because you want to spread around this thermal paste some. You don't want to just put a dab in there, jam it in, because it only stays on one side at that point. So I think that's what I'm going to do is just cut a finger off of this. And we'll just use the finger. Kind of like so. And this will let me spread some of the goop around. And I need to get a little bit down in that hole, put the bead in, and then loop the legs of the thermistor underneath that screw and then just screw it down so it's held in place. You do not want to crank down on that screw. You will squish these wires, which are very, very tiny, and then you'll be replacing your brand new thermistor again. So be cognizant, be aware. The other thing you can do here is like put some on your heater core itself and then use it like a toothpick to dip into it and try and fill in some around this well. But I'm going to put some of this over here on our our heater core. Kind of run a bead. And then I'm going to see if I can't get some of this squirted right down into that thermistor well. Trying not to make a mess. Pull that back and get this out of the way. Okay, so thermistor first. We're going to take this and dip it right down into that thermal paste. Try and bend those wires around the head of that screw. We'll hold it up here and tighten that screw down some. Tighten that screw down some. This is the screw that came with this block, so it feels like it just bottomed out. So looks like I will be replacing this one with a even shorter one. How is that bottoming out? There is no way that should be bottoming out yet. Hey Pete, how's it going? I think maybe I just got some crappy threads. Again, we'll get this back in there. You'll want thermal paste in there because the thermal paste is going to help transfer the heat to that thermistor better. Okay, and I just stuck my finger into the stuff that I was trying not to. Great. Now I got Arctic silver paste all over me. Now we're going to take our glove, because that's what we put our gloved finger on, and we're just going to wrap this around, kind of spread this paste around some so we'll get a little bit better thermal conductivity. This is just going to fill that gap between the heater core and the heater block itself and give us a little bit better thermal conductivity. Just like that. Make sure it's pushed down all the way in there. And tighten up your screws here by doing the right thing and using that finger that you put a glove on to I'm a hot mess today, gang. How's it going, Pete? Chewy? Hey, Chewy, are you going to Midwest this year? Now, this is a clamping force. You want to make sure that you get it tight, but that you don't strip these heads, because if you strip the heads, you're going to have a hard time getting it back out. So there's our little bead thermistor. Shove down in that hole. Notice that we haven't really cranked on that. We've got this in there and clamped on. It's held in good. Now we've also got a sock. I did order a couple of socks, and I have torqued this already to the 1.4 Newton meters that I have. Go ahead and put the sock on there. Yeah, that's the right way. So we'll have a nice little socky doodle on there. Keep things nice. Now, what I want to try and do is keep these wires coming over towards this side of the printer. The other thing I need to do is put a little bit of PTFE tube in here. Otherwise, we've got a gap where our tubing can move around. And I think these came out of, what did these come out of? These came out of my old MMU2 buffer system. So I've got a little bit of a chamfer in them, which is what we want. We're going to take this, put it right at the top, and we'll cut it right at the top of this. I need something to cut this on. That'll work. That down, hold it in place. Nice cut. Now, preferably, I would like to, there we go. Very, very small amount. Like I said, we're just filling in this top piece here to give us a good filament path. And I want that chamfer at the top as it goes from the inside of our heat break in here to this. Once again, I want my wires to be coming out the right side here. We're going to take and slide that all the way down. Make sure we're making good contact. And with the right driver, we will screw in this set point. And just like that, we now have our full filament path from the extruder through the heat break, cooling fan for the heat break, and to our all metal titanium throat, and into our volcano nozzle. And we've got our wires here. Now my thought, these two holes here are for induction probe sensors, which we're not using here. We're using a BL Touch. So I just want to pull these through. And I might do them in the smaller one here because I might need to bring the BL Touch wires in as well. Of course, these are the heater ones that had that extra bit of insulation on them. So we'll bring these wires in because all of our connecting wires are coming in here to include our motor wires. And you see me kind of holding off to the last. I need to make sure that everything's lining up before I pull this VHB tape off and push this on that VHB tape. So we also need to line up our fan. This is the part cooling fan from the 4020. We'll get that lined up. And this uses two smaller, put that away, two smaller screws. I actually swapped out the screws that they were using here with some shorter ones because it just needs to go barely through or just to the top edge of this. Having threads sticking out is a waste. It doesn't do anything for you other than give a sharp edge that can be caught on something and damage something. And since we have wires shoved in here, kind of don't want the wires to be. Hey, what is going on there? I am somehow not aligned. There we go. Now, this is the duct that came with the printer. And Houston, we may have a problem. That is not pointing directly at the nozzle. So what I want to see is the heat break longer? I think my heat break is longer. Oh yeah, definitely so. This heat break, the heat break I bought is longer than this. So that's the issue. Because I am fully seated in here. How do we address that? Part cooling fan off. Basically what I need to do is re-engineer this so it's coming at a different angle. And I do not have this part, so I'm going to have to try and figure this part out. And I really wish I had that part design. Let me see what I can do as far as a 4020 Volcano hot end or a fan shroud. Let me see what I can do. Because I'll show you the other thing I did was this has a BL Touch sensor on it. And the BL Touch sensor, it's a little bit not straight. Right? So I catted up a similar part, didn't do all the little fancy things here. And this is printed in carbon fiber nylon. So this is Polymaker PA612 CF. So same overall dimensions. As close as I'm going to get the placement of the mounting holes. And I made it the full thickness because this is just added geometry that to me doesn't need to be there. So we'll get this swapped over to this bracket. And to make life easier, I actually undersized these. These are 2.9, and I basically threaded them using a screw. I guess I could have used my taps, but I just used a screw. Now this is a 3D touch. So this is a generic version of a BL Touch probe. We don't know how good it's going to be. We've talked about whether or not we put on a real BL Touch or not. Let's see once we get this going. And if we have repeatability issues. I've never used a 3D touch, so I don't know if we're going to have repeatability issues or not. But this PA612 carbon fiber reinforced nylon should definitely not have an issue with being mounted right to the back of the hot end mount. Plug those up. I could probably even go with some longer screws because I made this a deep or taller piece. Hopefully, and that's going to help get away from that warpage too. Just the geometry here could have played in with that warpage. If this was full, full cross piece here, this would have been thicker and maybe have held up to that warpage some more. But yeah. I just got to make sure when I mount this in the right location. We'll have to figure out that fan duct. So this gets mounted back here. And when we go to mount this, all right, it's going to mount this way, I believe. Who's on that side? No, it was on this side. Might be because I'm running my wires there. Nope, that's right. Yeah. Hitting on these. Oh, okay. Now I know why that's there. I'm going to have to reprint this part. So this cutaway is there to allow it to clear the head of the screws that are just sticking up here. So that makes sense why that is there now. Okay. So I will have to fix that, which isn't that hard to do actually. Which way are we doing it? Which way did I do this? Home. Oh, that sucks. Oh, I wanted. So what I did was I was catting this up and main orientation. We started off with our sketch. And when I sketched it in this orientation and planned to just fill this in. So now I've got to take that out, which means in essence what I need to do is, so we did that. We did an extrude. We did some fillets. We did a chamfer on the bottom piece to allow for elephant's foot. And then we did another sketch. So what we need to do is edit this sketch. And what we need to do is basically move this entire sketch over this way. I did 20 millimeters over. So what I need to do, Should be easy enough to grab that, grab center here, that edge, call that 20 millimeters. That is now move that over to the other side. So we're looking at the part like this now. Now I can add the couple of millimeter cutoff to the top. Really doesn't need to be much. 15 millimeters in. 15 millimeters in. That's 2 millimeters. And that should be fine. Store and now finish the sketch. Come here, which was the extrude of our holes. Let me edit this feature. What are we doing? Reselected. Select that one as well. Say okay. Now we've got our cutout. We can make that cutout a little bit bigger to do the laying. Back and edit the sketch. Up. Here's the we make that 58. Did not move it. Bump. Oh, sorry about this. I'm just trying to play around. So let's go millimeters in. Millimeters in, 2 millimeters deep. That's good. Finish sketch. Forward. Edit this feature. Selected. Add that to the selection. Okay. That cuts better. We need to add some fillets. That one. That one. That one. That one. And what do you think? About 1, 2? Oof. Maybe not. 1.5? Unlike it. Cancel that. Grab this, this. So I'm trying to just put in this this chamfered area where these two parts come link up. Why is that one? Because that one did not get selected. Play. That one. That one. That one and that one. 1 millimeter. Doable. Okay. Ooh. Hey, Wilk Allen, how's it going? We are updating a part. Um, I had I had done this part and realized after the fact, after I had it printed out and all that good stuff, that um, yeah, I need to reprint it and with this little cutout here. I couldn't figure out why they did the cutout on this part here. And it's because there's some bolt holes that you have to miss, basically. So that's what I'm trying to do is allow for those bolt holes to be missed. So I'll have to reprint this out. This is Optimus P1 Pro BL Touch mount V1.2. And yeah, it's Rev 1.2. So what I will do is we'll bring this over here. We'll grab that, delete it, grab this, grab 1.2. Don't want to save it. I don't want to discard it either. 5520. I did want a strong part, so 45520. Okay, good. Now slice that plate. We're going to take this other one off. I'm printing this now in ABS because I've taken the nylon out. The nylon really needs to be dried, like 23-ish%, but still needs to be dried. So I will send this. This will take just a couple of minutes, like less than a half hour, 20 minutes or so on the bamboo. ASA. Yes. This plate. Front plate. It'll be done in a regular ABS. Still going to be better than the PET G that it was printed in, and we should have no warpage issues. I mean, this is definitely a strong part, but it was warping under load there. So we're definitely wanting to fix that bow and warpage. So this is going away. All right, so where are we at? We've got our heater stuff. We ran it through that spot. We'll be able to get our new plate in here because we have that cutout, so it'll allow it to slide up and down, which we can put on later. We're also, throw that around. We're also going to need to redesign this. The heat brake that I am using is longer than the stock heat brake. The stock heat brake, well, here, let me take these out. There we go. So, my heat brake, their heat brake, well, that's not too far off. That is not too far off. Oh, yeah, I guess it is. A few millimeters off there. And so what we're getting is this is now way too far down for that fan to hit it appropriately. So okay. And that screw is hitting this focus like right there at the upper edge of this piece. Same thing right here. It's hitting it right here at the upper reaches of this piece. So that's a little disconcerting. You'd think that it would be held on a little bit better. Now I could pop these out, run them through the front one, and then put the plugs back on the pins. It just makes it harder to get out. But that would also give me the ability to bring this potentially down up through the larger hole back here. And what that does is free up this space here for this larger cable, because we were getting some bending of this area here with the larger cables there that I had to actually do some fitment here real fast. Oh, I'm like, why is that? Yeah, because you'll see that this will fit on there around everything. And this is where you get your lever to open up your filament path. And your BL Touch is mounting through these lower holes into the front case here. So, yeah. So we're getting close. We'll need to redesign this, like I said, to make it a little less of a obtuse angle here. Drop it down a little bit. Sorry. We'll need to, instead of it going like this, we'll need it to drop down a couple of millimeters. Just change this rake angle. I have no idea how I'm going to figure this one out. gonna have to figure angle geometries and stuff out, and that's not me. I'm not there yet on my um, CAD skills, but we'll get that figured out. I'll have to CAD something up and print this. The good thing is I can plug this in at pretty much any point in time. I'll use it to set that front fan on, and then yeah, we'll be able to spur some things away. So what I'm going to do is I'm going to depin these so I can put the heads through here. The other option would be to bore out these holes some, but I would really want to take everything back off before boring metal there, number one. And then number two, the then it's not going to have the protective coating around that. So I'd have to figure out, do I spray paint it or what? So how are you doing tonight, Wilk Allen? Adam, how's it going? Who all's going to Rocky Mountain here in a couple of weeks? In about a month. God, it is about a month, isn't it? Oof. Yeah, so we'll stick that through. This is basically becoming a maintenance nightmare for me later on doing this, but me or somebody else. Actually, I don't know. If these wings aren't used for anything, we might be able to just cut those off. Are they used for anything? Not really. They're just... They help align some things, but they're really not used for anything. We could probably cut these off, and yeah, these will be able to go through there without these wings on. That's another way we could do this. So the wings kind of give you something to grab onto as you're trying to pull the connector out. Snips. I'm gonna snip these off. 45 days. Hey, Pez, there's my counter. How's it going? One side, then we'll get here and we'll do the other side. That's good enough. Cut these ones off too. My thoughts were just if we could route these up through these holes that we aren't using, it actually makes life a little bit easier cable management wise, because everything needs to be kind of out of the way over here. Making sure it's pushed in nice and tight. We'll lock this in. Yeah, that lets us bring our cables up in here. The motor cable, the same thing. I'll cut these off, the wings off. I should be able to get us up through the larger hole, which I think made for like an 8mm inductive probe. I think you've got basically for like either a Penda or the 8mm probe. And by bringing these up around, once again, that's going to make so that we can use this gap here for these size wires. That should be perfect. So I'm going to set this on and screw it in just so I can set the height of this. And then as long as I print this out using the same measurements, it'll snug up nicely to it. Okay. And what we could do is I can literally work on designing up the fan and still take this whole thing down to Echovate and get it plugged in so we can start testing the movement and all of that, because really I can't test the well, I might be able to test some movement with the um, without having the uh, toolhead installed, but it may bark at me as well. And like I said, we're just going to stick this on with some VHB tape. So I'll just take the film off the VHB tape. We'll get that fan lined up and stuck on. And I'm trying not to stick this on with enough force that I destroy the fan, ripping out the cables or anything when or if I have to remove the fan to do maintenance or anything on this. Come on. Okay. Now we just have VHB at the top, VHB at the bottom. I'm going to set this up right on the fan duct itself. Whoops. Line it up perfectly on the fan duct. And apply some pressure to the case itself. Okay, that'll give us our good fan blast going straight down. Now I'll be able to take this and figure out some measurements to be like, okay, this is where we need to make our adjustments. Oh, I have to, yeah, might have to redo that fan just so I can, might have to take the um, little bit off of those standoffs, a little bit of file action, but we'll have to work on getting this angle here. So I'll measure this all up, start getting it going. And I'll have to sit here and keep looking at the angle. BL Touch mount, we're reprinting that right now. Once we get that reprinted, we'll be able to get this installed, test fitted, tried out. This is going to be the cable for the extruder wire. And then everything else will be on the D cable, the BL Touch cable. Yes, let me do that. Let me take this off. This stuff will have to come off. I'll put some new VHB tape on there. But I need to take these down just a smidge with the file. They're a little bit too tall. I could reprint them in ABS. I think I made these 9mm. So I can make them a little bit shorter. Yeah, I made them 9. If I make them 8, I could potentially, no, I can't. I was going to say I could potentially take them off, but that would involve me taking the entire tool head back apart. I know I can do, I just don't want to. Not yet. I'm going to have to do it again anyhow. So we'll use a file. We'll go ahead and take the fan back off. We'll use a file to get there, and then I'll have to start working on catting up a new fan. Hey, Timor, how's it going? I keep trying to look for um like parts for an Optimus P1. There's no parts. I don't know there was a disk that or a USB drive that came with this printer. None of the printed files are on there, so if we want to redo these printed files, we have to basically recat them ourselves. I can't seem to get anything out of FebTop. Yeah, 45 days. Dang. All right, that means I have to just get started. I need to get the I need to get the Death Racer done for Mrs. Dragon. I need to get the um whatchamacallit done for KB3D. I'd really love to get like a circle. Let's see what we can find on the interwebs. Let's see what we can find on the interwebs for a fan duct. Oh, hey, Polymaker Palooza, folks. I know Pez had a full up stream on this earlier today. I was watching it. It was hard to catch everything you were saying, Liz, when you were muted. Not because I didn't want to listen to you, but I was sitting in a meeting. So just try things like go to things. So what do we need? We need a 4020 volcano nozzle duct. I can't even see these pictures to see if they would even remotely work. No. Look, imagine that, an Ender 3 fan duct. Yep, nope. Oops. Not paying attention. 4020. Oops. Forty-20 volcano fan duct. I'm just trying to see if there's anything that would give me a starting point. Yep, nope, not really. I'd love to be able to look up like a might be worthwhile to look at that and see if I can't just grab the bottom of it and left it on. Ah, let me actually stand up here so I can see. that over there. That can go there. This stuff can then go whoop, forward. That stuff anymore. How's that going to work for a volcano? That does not look like it's low enough for a volcano. But I kind of like that area. BQ 4020 fan duct. I kind of like the little ring ducts because you can get air in from both sides. Yeah, see, something like that might not be bad if we can take this, modify the top to be able to do the mount piece and just kind of graft it on there. That could give us better air circulation around the whole nozzle. Now that's not a volcano style, so we'll probably have to still do a drop down, but that shouldn't be that hard. At it from the side. Yeah, so like I said, I'm just pinging around here looking for ideas. Here's what I'm looking at. This here would be another 4020 fan duct that kind of loops around. So that could be another possible piece that we can grab and just make an extension for. Do some selective cutting and whacking, and because I am by no means a fan duct person. And I would really love to find, a correct mount for this, but it's just not going to exist. 4020 blower fan. side. No, let's see, 4020 lower fan duct or volcano. See if that helps. Tier 3 4020 lower duct. I don't know. Not sure if you guys want to hang out and talk while I kind of dink around and look at this, or if we should maybe just find a good stream to jump out to. Not too sure about that one. Oh, all right, yeah, we're gonna have to figure something out here. Okay, folks. Like I said, I don't want to hold everybody on here. I'm kind of at a stopping point. I really wanted to get this done, but I'm going to need to do some filing work on the fan and some rework of a fan shroud or a fan duct of some sort here. I'm going to try and look at some designs. Like I said, I at least want to be able to come in from two directions. But yeah, I I am not a CAD person. I've CAD'd up a few things. Um, you know, simple little brackets like this have been fairly easy. Fan ducts, I don't know. That one might be a little bit harder for me to work out. So I'm going to see if I can't elicit some help there or make something work. Um, but for now, I think we're as far done as we can. I've got the new bracket printing for the BL Touch. We'll be able to get that put on, and I'll be able to start working on tidying this up some. But yeah, I think that's kind of where we're at. I can file a little bit while we chat. And like I said, I'm just going to work on filing down these standoffs. If I reprint the standoffs, then I will have to I'll have to take this whole thing pretty much apart in order to um, replace these, because the screws are coming in from the backside. We won't be able to get to them. That's where I said it might just be easier to file these down. We're only trying to take it like down a millimeter. It's not like we're trying to take off an inch or something. We're just trying to take it off so that we can get the fan back, just the front fan back just a tiny bit more. Closer. Trying not to get onto the metal. That was ABS, so not like it's gonna take a lot to get that off either. And that was all I needed to do, was that much. So that is ready. That'll make it a little bit easier to secure this fan down, like I said, with some VHB tape, and get a better seal at the bottom here. Okay. Sorry about that, folks. Hey, Shrimp Father, how's it going? Um, so I feel like I'm taking 2 steps forward and 8 steps back. Or at least on this particular build piece here, because it wound up that the heat break that I bought was about 3 to 4 millimeters longer than the stock heat break, which I definitely wanted to replace because it was PTFE lined. And that means that the cooling fan or the cooling duct here, kind of doesn't line up anymore. So I need to redo the cooling duct and either, make a flat bottom rounded duct, or recad this at a different angle so that it's coming out by the tip more. Either way, that kind of CAD is not my forte. So yeah, definitely not my forte, and I'm going to need to play around some, trying to recreate this part of the mount, the base part of the mount, and then I can play with getting this angle right, because we need to shift the angle down. And I'd really like to do something more along the lines of, let me see if I can't open this up. So something more along the lines of this, where we're getting, whatchamacallit, we're getting air out in multiple sides of the tool head itself. Now that won't work. Yeah, because that's kind of off center. We'd have to adjust this some to where it was more of a centered loop rather than a off the side. So this might have, like, this piece would have to be moved over more in the center. Now we'd probably close off the center and force the air around coming from both sides. This might could possibly work. Um, don't know. We'd have to do some hacking and slashing on that as well. That's kind of what I'm looking at is how do I create a fan duct? And I'm going to start just by basically coming up with this base mount, and then I'll decide whether I'm going to do an angled outlet like this and just come in from the front, or if I want to basically do like a looped around, and how to do that. So I'll have to do some grafting ideas there because this type of CAD is not my forte. I don't know. It'd be great if I could find something that had a. Ooh, that does have a step. Might prove useful. But yeah, that's kind of what I'm looking at is just trying to find some fan designs that I can then use to figure out a fan duct design for this. The other thing that we could potentially do tonight, let me clear this stuff off. It's going to take these and, yep, right there. These are for the fan duct. These are for the fan duct. Toss that over there. This is going to go in the garbage. I had replaced that part with a this is a carbon fiber nylon. So this is Polymaker PA612 CF, and I did not put the little clearance cutout on it. So we're reprinting that now in ABS. We'll test fit it, and then I'll have to make a decision on whether I reprint it in the nylon, which requires me to dry it because the nylon's kind of getting wet. Which I might do anyhow, because if I go to do the fan Okay. Hey, Royal Nomi, how are you tonight, dear? I apparently decided to mute myself. Thank you for helping me notice that and fix that. Um, but hope you're doing well tonight. I just realized that that the parts that I ordered that claim that they were for this printer do not fit on this printer, or potentially um, the individual who is asking me to work on this printer for them has potentially swapped out these blocks at some point, which would mean, yeah, which would be bad. That's what that means. Not too bad, but it does mean that standard parts will not work for it. Um, crap, crap. I was really hoping that I can get at least one of these working tonight. Yeah, I ordered some parts off eBay that were supposedly for this exact printer model, and they are not. Um, so from looking at it, it does look like the right thermistor is still in good condition. So I left that one in place, just put some ferrules on it. However, the left thermocouple has it turned itself into a single wire. You can see that little piece of wire sitting right there. So it no worky. It doesn't do good temperature readings. So this is what needs to be replaced. However, the one that I ordered doesn't fit. It's apparently I'm going to double check, but I have a feeling that the correct size needed is a 4 millimeter. I'll be able to test that out here in a second. That's not what I was needing. This is what I've got some 4 millimeter bolts in here. So what I'll be able to do is just take this, try it out on this broken thermistor. Yep. I need a 4 millimeter thermocouple. And what I got was two 3 millimeter thermocouple. So once again, either what I got was not for this machine, or sometime during the production run, they changed from a 3 to 4 millimeter hole in the block, or at some point, the individual that gave me this printer to work on has changed the blocks out. There's a lot of ands and ors there. Frustrating one way or the other, because once again, I'm still not able to get this put together, and the other one I can't put together because I have to I need to CAD a new fan shroud or fan duct, which is going to really test my skills a bit. I want to put at least one zip tie around this so it doesn't come unraveled. I'll have to cut it back off later, but that way that stuff doesn't come apart. Put that in there. Be able to set this up. And yeah, so I'm just getting kind of stymied at everything I've tried to do tonight, which is a bit annoying, but that's what happens when you're working on printers, right? Hey, old fella playing XX, how's it going? There's voice behind the person. Yes, yes, yes. I apologize. Apparently, I didn't realize it, but I had leaned against the mic, and when I did, I muted myself. So, hey, thanks. 1, 2, 3, 4. Thanks for the 500 biddies. I appreciate that. I really do. Um, I've been having a long talk with myself. I do that from times to time. Sometimes that's actually not a bad thing. Then I'm talking to myself and not everybody. Okay. To make my life easier and so I do not lose things, I'm going to put the bottom plate back on here. I haven't done all the zip ties and stuff like that. I'm not going to be running the printer. I'm just going to close things up until I get the parts that I ordered from the other location. Once I get those in, then I can take this back apart and we'll give it another try. But if I don't put all the screws back in it, then I'll have to go finding screws that fit because I will lose the screws. And since I'm working on this printer for someone, I'd prefer to give it back to them in the same or better condition, preferably the better condition. You know, they sent it to me not, or brought it to me not working. I really should give it back to them in a working order. So the Optimus P1, what we can do though is play around with that a little bit. As people are popping in. Okay. So that's plugged in, that's plugged in. This can go over here. We'll manhandle this back up onto its legs. Not busting the door. Very good. That. Got the rest of the extruder bits. The left extruder motor, the right extruder motor that is sans extruder right now because we were putting it on the other printer. Don't worry, I've got replacements coming in. That goes there, that goes there. Question is just whether or not the other parts I ordered get here before Friday or not. Move cables out of the way and set that right back down there. Awesome. Okay. Move a couple other things around and I will bring the electronics bin or case up for the Optimus P1 printer. Once again, this is a printer that was donated to Ecovate 3D, which is a local 3D printing shop. I have spoken with the owner, Beverly, both during the show and several conversations back and forth today. And we're going to start doing maker meetup / hangouts. Apparently, I'm now going to be running those. We're going to do them monthly. And of course, the fun about that is I wanted to get those started sooner rather than later. And we've got things like Rocky Mountain Rep Rap Festival, Easter, Murph, and other things coming up. So we have to work around that. But what I'll do here is this is the electronics box for the Optimus P1 printer. And I'm going to try and set some things up so that we can do some more testing to make sure that things are working. Okay, we get these things out of the way. I don't think they need to be there. And I've already played pickup sticks once already. this is the fan duct that we're going to have to reprint because once again, um, it doesn't line up with the tool head. So I'm going to have to, well, and when I say reprint, I mean I've got to redesign and then print the duct because there's no parts that I can find for this printer. I can't find any of the files. The BL Touch mount, I basically went through and had to recreate on my own because the existing one was warped. So, and this blower fan is going to have to be VHB taped down. So I need to make sure that it lines up, and then we can put a little bit of VHB tape and secure this with VHB tape because the holes on the 4020 blower fan do not line up with the holes on the 4010 axial fan. Because why would that happen? I mean, if I could at least get 2, that would be great. Yeah, I can't get 2. So we'll line this up. We'll just VHB tape this particular fan on. That'll be fine. We did go and do standoffs here. We got rid of the white plate that was through here because it basically created a vacuum seal on this fan. This fan is now going to be able to breathe. There's openings on 3 sides so it can actually pull in air and cool. But what I was kind of relaying here was we did quite a bit of work in here to get things cleaned up. All the wiring into the motherboard power section here was all done without ferrules. It was bare wire coming in here. So I pulled each one of these out one at a time, added ferrules to it. Same thing for the stuff coming over here. So this is the Z motors over here, these big external drivers. So we're coming out with the 3 wires into the first one. We're jumpering those 3 wires to the second one. The looped connections here are all the grounds. So we're just connecting all the grounds together. And then we've got ground and 24-volt DC. And then these are the actual 4 wires that go out to the motor. Down here, I was having a hard time. I ordered some new terminal blocks and they wound up being the wrong size. So we just went Wagos. So we've got the 110 and 110 inputs because we've got 2 110 inputs coming in. So we've got our 110 over on this side. And then this side is all of our 24-volt stuff. So one of our power inlets comes in and it just runs the chamber heater controller and the chamber heater. The other one comes in, runs the bed and the 24-volt 800-watt power supply that runs everything. And you're going, well, if it's got a main heated bed, why do we need an 800-watt power supply? Well, that's because these motors up here can pull 4.8 amps. These are driving NEMA 23 motors that are raising the bed. So it's a 600 by 600 bed with 1100 millimeters of build volume. And that bed is riding on ball screws. So think about this like true CNC machine type stuff. Okay. So normally what we'd have to do is fake our way through some of these thermistor inputs. We're still going to need to do that for a couple of them, which bed, and that's thermistor 2, which it really is not going to get anything from, but I might need to, I'm going to pull these 2 out I'm going to grab a couple of dummy thermistors, just standard glass bead thermistors, 3950s. I say dummy because they're just going to be standing there or sitting there. They're not going to be connected to anything. But you've seen me do this trick before. It's going to keep it from thinking that it doesn't have a temperature reading and therefore goes into a thermal runaway prevention. We'll just plug one in, plug the other one in. Okay, so that's the bed and the secondary thermistor. The chamber thermistor is still going to throw an error, but it's not connected to the actual controller board in any way, shape, or form. So that won't matter. I'll take this, I'll set it up. Semi cringe when I do because there's screws at the bottom of that. Let me undo these wires. Get these plugged in. Okay. And so you should see that we're getting ease down here. That's because the thermocouple for the chamber heater is not connected. So this isn't going to be reading anything. It's going to be in an error state. We have a switch here that's off. So what we've got is 24 volt from the power supply goes into a 3-pin Wago. It comes out of the 3-pin Wago to one side of this switch. The other side of the switch comes up to the emergency stop. The emergency stop goes to the 24 volt rail, which is two 5-pin Wago connectors connected together. Okay, now what we can do, we don't have any of the motors connected, but what we can do is look at our cables that we have here. We've got E, which has the extruder, D, which has everything else in the tool head. So let me do some temporary wiring. Thermistor. Heater goes to heater. The fans will be the only 3-pin connector left. And the BL Touch, or in this case, the, whatchamacallit, this is the 3D Touch, is right there. And this is cable D. These are keyed, so they only go in one way. And there's a really long cable that connects these together. Oh, you can't even see it. Boop. So there's another long aviation cable that connects these together. This is cable E. Once again, the only thing on cable E is the extruder motor. It would also be the laser. So this does have a provision for a laser of some sort. Yeah, thingy wasn't the right answer. So we'll plug in our extruder motor here as well. So basically we have everything plugged in for our hot end, and we can kind of validate some things, right? So if everything's connected, we should be good. We shouldn't see any smoke. I've had this turned on in the past, like at the last stream, and there was no smoke. So I'll angle this slightly as much as I can. we're going to go ahead and hit our power switch right down here. So once again, this is providing power to the next stage, which is this button. This button is pushed, so it's disconnected. What I'm going to do is I'm going to turn this and it'll spring up and things should come on. So I heard our BL Touch do its thing. It's bleep blooping now. Let's actually let's shut things off, and we'll do that again. I think this kind of really wants to be sitting in this manner. So we'll bleep bloop this again. So our 3D touch, whoops, our 3D touch is working. It did its little thing. Once again, we'll flip through that, right? So we just hit the emergency stop switch, which is how you shut it off. We'll flip this open. There's our 3D touch doing its thing. So our 3D touch wiring is working. See if I can lay this down and not damage it. The next thing that we've got is we can test out all of our other toolhead accoutrements, right? So see if we go control. We have nozzle temperature of 23, bed temperature of 22. The nozzle temperature is this thermistor. The bed temperature is the one that's sitting down there next to the control board. See if I can hold this by the motor. Now, extruder. Let's, can I do that? No. Nozzle bed. Nozzle is off. Let me see, can I set it to 200 and does the nozzle start heating up? So my nozzle is still reading 23. Whoops, and I just hit the power switch. That was nice. Control, nozzle, 200. It's it wasn't heating up because it still says off. So I have to, yeah, you have to click it to turn it on so you can set the temp and then hit the button to turn it from off to on. So now I'm seeing the temperature rise up on the nozzle. So that's good. All right, yeah, it's getting there. 124 C now. So this is going to go up to 200. Now what I want to do is my hot end fan spinning? And the answer is yes, my hot end fan is spinning. And even with this fan sitting in front of it, it can suck in air and blow out over this heat sink in the back here. So that's good. Let's see if it overshoots. And if so, how bad? I don't know if I can bring you guys and gals in. Can I get you guys the for the a little bit? As far as I can get you in. But you can see our temperature graph up. It's at 201. It is heating up. I felt that. So that's good. Getting a little bit of with, but it's brand new components here, so that's not surprising that you get a little bit of a smell, right? We're breaking in. It's a brand new heat break. It's a brand new nozzle. It's a brand new heater block. So, and we've got thermal paste on the thermistor and the heater now. So all of that, we'll say breaking in. Now, if I go over to extruder, I've got the out, the in, unload filament, low, medium, high speed. And what I'm going to do is say high speed in. And when I do in, I would expect to see this gear right here rotating towards me because that's going to pull the filament in. And it is moving in that direction. So that's good to know. And here, let's make a mark there. And you see it is moving towards me as I say in, which is going to be pulling the filament down. If I say out, it's going to go the opposite direction. So that means things are working in the correct direction. I don't know what it just whined about. Nozzle, I'm just going to, oh, I want to say off. There we go. So the screen's a little touchy, but I clicked off on the, next to the nozzle, there's an on or an off. There it's turned on. Now it's turned off, so the heater's turned off. It's going to start cooling down. Now, I want to see if I can figure out the part cooling fan. Motion. I can't mess with the motion yet because we don't have that set up. Extruder does not give me anything here. Laser, we're not going to be doing. More, power off, settings, G-code input, disconnected, end stops, home. Yeah, it doesn't look like I'm going to have any way of testing that the part cooling fan works, except for trying to run a print, because there's no dedicated fan control that I can see. Once again, this is Marlin. And I have no Marlin configs here. So what I was hoping for was I could get into the more. I could get into the more and setting and come down through here and be able to pull some stuff. Beeped at me again. I have no idea what the beep was for. It beeped again. We have a baud rate, end stop setting, temp presets, build dimensions, 600, 600, 1000. So that's good. Printer firmware. There's nozzle PID, home offset, Z probe offset, motion setting, and persistence. So I can pull the PIDs. So what I'm going to do is work through these menus and copy as much as I can down, because we have a brand new hot end set up here. We're going to have to PID tune this. I need to get all the motion settings because at some point I want to get this started and I want to get this printing. I wish I knew what it's beeping about. I don't know. Shut down after cooldown. It might be complaining because it's not getting information from other things, right? But this is giving me a good benchtop test that things are working and the toolhead stuff is working. Like I said, the hot end fan is still spinning. I believe, yes, the hot end fan is still spinning. I'll be curious to see if the hot end fan stops spinning at, say, 50C. We're at 131 now. It may be complaining because of, like I said, it's not getting input from various things. I have zero idea how this Marlin firmware is set up. I have reached out to the company to try and get information. This is a customized version of Marlin because of all the screens and stuff. Once again, this does have a laser option that I'm kind of sort of glad they don't have because, like, I would be fine getting an H2D. I don't want the laser version. You should not be printing and lasering in the same chassis. All right. When you laser, things smoke. You get all kinds of grit and grime. And there's a reason why those laser systems have very good vacuum and filtration systems. And they're different filtration type systems than a 3D printer. Okay. That soot's going to get all over linear rails, rods, what have you, and it's going to require a ton more maintenance. And if you read through the maintenance requirements for running the laser on the H2D, which is very much in fine print, you'll see what I'm talking about. So you get an H2D, just keep it in 3D printing mode, or just get the laser only version, or only use it in a laser. You should be fine, but yeah. So, but Royal Nomi, how are you feeling tonight? Should be doing or feeling a lot better, right? At least I hope so. All right, we're down to 105, so it's cooling off slowly. Let me see where we're at on this print. I don't know why. Actually, I do. I need to do some maintenance on this. Here is the new version of our print, complete with a little cutout area. So we'll see if that will fit and slide over the screw heads, or if we're going to have to adjust it a little bit more. That should just be, take this, set it up against the back of the tool head here and slide it. And that's going to clear those heads perfectly. That we probably only need about 1 millimeter, not even as much as we've got. So I'll be able to swap that over here in a couple of minutes. I really am going to need to grab my little notebook, and I will spend some quality time with this printer or the control box tonight trying to pull all of the Marlin configs. The other day on stream when we were working on this, we were writing down we were taking notes about where every pin on each connector went. So these connectors on the top, and there's one on the back that does the heated bed, and then there's a separate connector that comes out for the heated chamber. Um, they're 14 pin aviation connectors. It's weird because there's 14 cables to them, and I'm looking and seeing 8 connectors, unless there's more on one or two of these. Um, oh, grounds. It'd be a common ground. Anyhow, um, so there's 14 potential wires coming off of these connectors that go to the board. So what I was trying to do is map connector A, pin 2 goes to this connection on the MCU. Um, the plan right now is to run it stock, get some prints through it, see what can be done. And then I know Waters, which is one of the guys there at Ecovate, is really interested in seeing, um, like, can we clipperize this? And that's where pulling all the Marlin settings is going to really help our ability to clipperize this, as well as having all of the pinouts so that we know this connector goes to the signal pin. This side of the connector went to a ground, because this is an MKS Gen 1.4 board, which is an 8-bit board. If we go to, say, throw a Manta MP5 in here, we'll have uh, the the host computer with a CB1. We'll have the needed stepper drivers. We would, the chances are the pinouts for, say, a end stop or the fans specifically are normally what I see different. They may be reversed. And if you're not paying attention, you plug the wrong thing in and then you blow a fan, and now you're sourcing fans and potentially have damaged other things in the system. Um, we're still up there. We're at like 73 degrees, so that fan is still running. Thing cools down really, really slow. But then again, there's no part cooling fan blowing any extra air on it. We do have a silicone sock on it, which is helping to keep that thermal uh, mass, or the thermal heat in. This is good. And eventually, I know the other reason we want to clipperize this is I have zero idea where the the thermal cutoff is on this. Right? It was, from what I could tell, it was a PTFE lined hot end. And what I've seen on some forum posts that are few and far between to come across, people have swapped out to all metal heat breaks like I did on this, and they've had to go and get custom firmware sent to them by FebTop that allows for higher temps. Because my goal here is, right now this has got a 0.6 hardened steel nozzle in it. I'm going to have another complete setup so that we can basically undo the thermistor and heater wires, loosen the set screw in the back, pull the whole heat break out, stick in a new heat break, and route the wires up. And then we'll be able to have an all metal hot end with a PT1000 thermistor with a 65 watt or a 100 watt heater, pushing a 1 millimeter CHT vanadium nozzle. So we'll be able to print big things faster, or should be able to print big things a lot faster, because we'll have the ability and capacity to push a larger amount of material. And I'll actually start off, I've got a cartridge thermistor already set up. That's a standard HTC 100 that should work with this. Once again, it's just a matter of, please check the auto shutdown model. Okay. Okay, the nozzle's down to 59. So that could be where it's complaining about something where it can't do a shutdown. Don't know why. But I am keeping an eye on this fan. I want to see this fan kick off at around 50 degrees Celsius, which would be the normal standard. The old fella playing things. Um, are you here in the North Carolina area, or just trying to figure out if I've met you over at Echovate for their grand opening? We're getting close. This thing takes a bit to cool back down once you take the heat off of it. Like I said, it just might be that the cooling fan's not also blowing on down there to help cool things off. But I will tell you that this is a brand new 6020, a brand new 4010 axial fan to cool things off. The the 4010 hot end fan was how can we say this? It was Bluetooth, meaning the wires had completely severed off of it, and the fan itself, the bearings were toast, which is probably due to the fact that it had a solid spacer around it, and it was placed right up against the backside of this fan, so there's no way for air to get in. So it was being starved for air, and basically it was it was creating a vacuum trying to cool the hot end down, which might have been part of the reason why it appeared to have had a thermal event, because I had to scrub this whole mounting plate down. It obviously had a thermal runaway event based on the look of the plate around the heat break. The fact that it looks like it had a brand new thermistor put in that was crimped for some odd reason, and I can't get it out of the block. The original block that came with it is extremely light, which is indicative that this is an aluminum block, which means it's going to be thermal limited to how high it can go. Right now, the one that's in there and the other one that I will put in for the I'll say the higher temp version is a nickel plated copper block, which means it can go up to 450 degrees C, which is what I want to try and do. I want to be able to print, say, TPS CF with it. I'm not going peak. Peak would be a level I'm not prepared to go to myself yet. Definitely not in a printer that's sitting in a shop environment. And when I say shop, I mean a store environment, because we need to be cognizant of people in the store. But this thermistor is also not coming out without some percussive persuasion. It is jammed in there, and they have somehow um, crimped that connector, which means it's no longer round, which means it no longer goes in and out very easy. So they've wedged it in there. And quite honestly, it's an aluminum block. The only thing is that I don't know if the thermistor itself's good, but chances are I'm going to make the thermistor not good trying to hammer it out. So I may just take this whole thing and toss it, because it's not going to be good for anything I want to do with it. So this cooling fan is still on. We're down to 42. It should be like, it should have stopped at 50. I wonder if that's what the issue was that we were getting on the auto shut off not doing its thing. But yeah, apparently the fan's not shutting off. While we're here, let's go back into settings. Printer firmware. Once again, we've got the build dimensions. Um, 600, 600, 1000. Printer firmware. Nozzle pit. This is something that we will have to redo, which means we're going to wind up having to connect in via USB to run commands or issue commands and do that kind of old school shenanigans. 14.47. 0.09. 48. And 1.0. Home offset is zeros across the board. Z probe offset currently -4. And that's going to have to be recalibrated or recalculated. Motion settings. X, Y, Z, and E. 80 and 80. Which is weird. No, maybe. I've been thinking in Clipper for too long. 2,560 steps per millimeter. Wow. For the Z-axis ball screws. And 189.5 for steps per millimeter for E. Printing model Excel. Is 1,000. Travel Excel. 1,500. Retract Excel. $3,000. Okay. Max Excel. Um, 300, 300, 100. And E is 10,000. V jerk. Y, Z, E. X and Y is 10. E is 0.3. E is 5. Sorry, guys. I know this is like, I don't know, watching paint dry. Hey, Waters. I am currently in the process of copying down all the Marlin configs that I can get to. Feed, right? Because caught the stream before it ended. Yeah. I'm currently trying to pull everything that I can. The max speed and min travel speed or excuse me, min speed and min travel speed are 0. But I will tell you that I have had the toolhead up to 200. See, you only just got home about 30 minutes ago. Okay, cool. So, couple of things. One, the fan's not kicking off, so that's interesting. Um, the extruder is moving in the right direction. The part cooling fan, I've got no way of turning the part cooling fan on other than um, like during a print. So that's annoying. Configuration will save to EEPROM, enable EEPROM settings first. That's the persistence piece. So we did the printer firmware. We've done the build dimensions, temp presets, got PLA and ABS in there. I'm just trying to pull all the existing information. I told the hot end to heat up. The hot end heated up. So we're getting good. Currently we're running the hot end thermistor, and then I've got 2 dummy thermistors in the board for the bed and the other hot end that's unknown. The BL Touch did its BL Touch thing, or the I remade the bracket. This is ABS. I printed one in nylon, PA612CF, and I didn't put this piece here because I didn't think it was needed. And it's needed, so we needed to make a revision because this is where it slides up over the bolts that are holding the heatsink in. So this is ABS, should be fine. If you want, I can reprint it in the nylon and we can swap that out later. The fan duct, the part cooling fan duct, as you may be able to see here, let me pull you in. I'm limited because I'm cabled up and powered on, but the fan duct angle is wrong. So I'm going to have to cat up a new fan duct. Oh yeah, should be fine with ABS. It's only got a 50-watt heater in it. I thought I had 65 watts. I don't. So I think I'm going to order some 65 watts and maybe 1 or 2 100-watt heaters. But yeah, I'm going to have to CAD out this fan duct. I can't find any fan duct that will work. Can't find anything for the Optimus P1, by the way, regardless, any printed parts. So I've CAD'd up the BL Touch mount. I will CAD up a new fan duct of some sort, unless you want to. The part cooling fan's working really well. I currently have the extruder from the TD Tech X Pro that I'm also working on. You're morbidly curious? I have no idea. My Google Foo has not been able to find jack or squat on it, and they haven't responded back to my email. They sold me stuff, but they haven't actually like responded to an email. Well, we got temp preset. But I figure I would document all this stuff, create a little spreadsheet like I did for the wiring diagram. And like I said, we're going to have to get this connected up to test anything else out. And quite honestly, I mean, this duct will work for the time being. Not ideal, but other offices are listed as permanently closed on Google. Oh, well, that's great. In stop setting. Um, must be consistent with your machine. So the X end stop was on the right hand side of the machine, right? Right. It looks like this is set men, men, and men for XYZ. But I think it's the, yeah, X right, Y front. That would be X max, Y men, and of course Z men because we're using the BL touch. That's what I'm saying. We'll have to figure that out and validate that once we have everything on the machine and we can test movement on the machine. Baud rate, 250,000. I don't know why that matters. I mean, I know why, because we'll need it if because I'm assuming we'll wind up connecting with, probably like a laptop and going via Interface or something. Yeah, Octoprint Repetier. Yeah, that's what we ought to do. Is if I can get this connected to Octoprint or something, I could pull the configs manually or that way as well. Um, I kind of like doing it this way anyhow. It was throwing me off a bit. I was looking at the like the steps per millimeter, and it was like X and Y. Was X and Y were 80, and I'm like 80. It should be. Oh no, that's steps per revolution. Stop thinking clipper. The the Z steps per millimeter are like 2,500 something. It was crazy. Yeah, 2,560 steps per millimeter on the Z. Moment, run out sensor on. I'm gonna keep playing around. I'm gonna hit that. So what other Big True Tech Pi 2 big gear reduction? Yeah, it is. Um, it could be crazy micro stepping. And once again, I'm not even sure because remember the dip switches. I'm trying to remember, was it the um yeah, what micro steps and amps. It was the amps that wasn't set on the one that was not mounted or hung or connected, right? Absolute unit of a machine. Yeah, I think they were talking about like point 0.1 layer heights. Oh, and uh yeah, it might be point zero 0.01. And not going to hit restore factory at this point. We need to get everything first, and then we can mess with things like that. And this thing doesn't have a Wi-Fi module in it, so that's good. Yeah, not going to do the language or setup wizard. Okay, so I've got everything written down in case anything goes wonky. I don't have an Octopi set up yet, but I can set one up. I picked up a bunch of Raspberry Pis over the weekend, so I can set up an Octopi and speed you need to push at 0.01 to match your max volumetric flow. Oh yeah, oh yeah. Like I said, this thing right now it's got a titanium heat break, a 0.6 hardened steel nozzle, 50-watt heater. Eventually, I want a 65 to 100 watt. We'll see. Like, I don't want to jump to 100 watt just because it'll at least go to a 65 watt heater with a PT1000. And oh, by the way, I have a Bondtech CHT vanadium nozzle coming in a 1.0 millimeter size. KB3D had them on sale, so yeah. But the hot end's hot ending. The cooling fan appears to be in always on mode. Don't know why. As in the hot end cooling fan. But no, that makes sense. I think that does make sense. I grabbed the original PID settings. We will have to change those, of course, since we've got an all new hot end setup going on. Undo that. Undo this. Oh, there we go. The part cooling fan was going to get just VHB taped on because it is not lining up with the same holes used by the other fan. So the best thing to do is VHB it on. And then, yeah, because even if I flip that the other direction, it's not going to do it, is it? Obviously not. Yep. I'm just going to VHB tape that onto the mount. Get it lined up, VHB tape it. And then when I redo that mount or the fan duct, that will get covered up. We move this over here out of the way. I'll get that squared away. The extruder motor one. Hey Tim, how's it going? Ford 5M Pro, 200 bucks. 5M Pro. The Adventure 5M Pro? Is that what you're referring to? We also put some MX4 thermal compound. We put that on the thermistor and the heater. It was like coming over here to flip a switch, but all the switches are on the front. So what I need to do now is just unplug these. And remember, yes, and that's why the hot end fan is connected. Well, that's to ground. You've got power always coming in. You've got ground here for the hot end fan, or at least what I thought was a hot end fan. This must be the switch for the cooling fan, and the other fan, which is the hot end fan, is always on. So as long as the 24 volt power is running through the board, the cooling fan on the hot end will always constantly run. I've got my typical dummy thermistors in here to trick this thing so that we could run it like we were just doing it. Come out, come out. There we go. There's one. Gracious. These are some good JST connectors. Okay. And that one goes in the middle. And that one is the other one. There we go. All right, so all the connections are back in there. I don't know if you saw the wiring that I did, Waters, but I wound up going with all Wagos. Let me get these cables done up, and I'll flip it around and show you again. But I did decide to go with just do Wagos because the terminal blocks that I bought wound up not being the right size. So there's the power. We've got our 110 coming over on the side. And then in the 3 counts. And then the setup here is 221 415s side by side. I just jumpered them together. And then right up at the top, and I'll show you this more in person, there's a 3-pin up here, which is 24 volt up to the 3-pin. The one that comes to the front power switch, then it goes into the e-stop switch, and the e-stop switch is what comes down and joins to this bottom power rail, basically, that applies 24 volt everywhere. So everything's cleaned up. It is safe. I did not reinstall the fan over here. The plan, my thought was, because I know you guys have it, and if not, I've got plex or not, is it plexiglass, acrylic, one of the two. I could cut this out. I mean, it's a straight rectangle, right? I could cut this panel out. We'd have to, I will cut the panel out, and then I just realized that these are not at, I don't think these are all lined up vertically. So we can do a clear panel, line up, and I can drill the holes for it. And then what we can do is laser out 2 fan ports, maybe 1 ingress, 1 egress. And that way we can get air running through here. I mean, there's plenty of egress holes in the back and the bottom. I guess we can do like 2 ingress fans and direct time to 24 volt. That way they'll be always on as well, as long as the 24 volt rail's turned on. So yeah, we can either run both egress or both ingress, either way. It's just whether you want air blowing down on these or sucking out across them. Doesn't matter. But yeah, that way we could do that up here on this front cover. Because I know you guys have a laser that you can laser it. I'd have to mill it with my Capoco, which I need to actually whatchamacallit, I need to redo my wasteboard. It's a mess. I tried cutting panels on it the last time, and it didn't turn out as nice as it normally does, and I wanted it to, because I need to redo the wasteboard. And we could probably go ahead and get some clean fans. I mean, at least this one's spinning decently. So the bearings aren't completely shot in this. Absolutely no idea if it's dual ball bearing or not. But yeah, it's all cleaned up. I'm going to VHB tape this. I will swap this out and get that on there. This fan duct can be pulled down and off as I go to redo it. That's no big deal. We should be able to get this closed up, and I'll bring it in with me tomorrow. Hey, Evil Diesel, how's it going? You've missed all the fun. We started working with this. I got frustrated because the fan duct, yeah. The heat break that I bought for this is a little bit longer, so it's not ducting in the right place. So I have to take this off and completely redesign or rebuild it. Yeah, redo it. There we go. I cut the little wings off of these connectors so they could fit up. This, I believe, is for like a Penda probe, and this would be for an 8mm probe. So that just allows us to run the wires a little bit nicer. The extruder motor I'm going to run up from the underside. I might take this and turn it, lock it to do that a little bit easier. But the whole purpose is to get the wires in there nicely where it's not all kinked and jammed up. But yeah, this is going to come with me. I'll put it back in the truck when I go into the office tomorrow so that we can get that mounted. Hey, Evil Diesel. Get done. Bottom or the front sitting over there as well. So we're getting really close. At some point the extruder will come back off of this. I hope I can get that out without having to undo all of it. But the reason I'm saying the extruder itself will come off is because I have a metal version coming in. So we'll be able to play with this and get it printing. And then at some point, we'll do another upgrade cycle on this. This will go to metal. This will go to a 1.0mm nozzle, a 1.0 CHT Volcano vanadium nozzle with a 65-watt heater or potentially a 100-watt heater, BT1000 thermistor. We'll make it hopping a little bit. Okay, so I think I'm just going to do top and bottom with some VHB tape that I put back over here somewhere. Which brand TPU? Yes. I don't want to put like a big amount of like I want enough tape on here that it holds this in place, but I don't want a lot of tape on there that where I will basically be breaking it to get it back off if we need to do some work on this. So it's kind of a Bilaflex TPU. Awesome. So Waters, what I was starting to mention earlier was I was talking with Beverly today and I threw out dates for Maker Days at Evocate. They're going to be Saturdays. We're going to start in April. It'll be a morning day and then an evening. Well, I say morning, noon to 3, and then 4 to 7 for the evening ones, which is 4 to close, right? So, goodness gracious. I'm going to do up like a flyer, but the plan will be to do a like a Discord event so that we can kind of see how many people are coming so we know how many tables and stuff like that we might need to set up. I'm saying this because she's like, you'll need to talk to Waters about doing the Discord stuff. Which means either have Waters do it or Waters is going to say like, hey, here's, you now have access. Okay, 1001, 1002, 1003, 1000. Okay, so that's there. I need to take this off and figure out how to start modeling it up. I would really prefer to have like some type of ring, but it'd have to probably come in from this side or something with the way this is going. I don't know. We'll figure it out. Straight works for now. It'll get us something. That cable comes in like that. And how are we going to get the BL Touch cable back out? That's a small connector. We can feed that through. And do that there. That down. There. Go up through here. So I'm trying to go up through these pre-existing holes rather than through that side piece. That way we can put both of the cables in here and not jack things up. Because it was starting to look like they were a little pressed. That makes sense. Do something along the lines of that. We get the front case sleeve. Things are there. We need these need to have washers on them. Yeah, the cable pass-throughs can definitely be optimized a bit. That's a kind of a down the road, like to have type thing. All right, what's going on here? I have a black one, or actually, I probably do have a black one. Get a black one. Talking to myself. Yes, most definitely. Okay, so those two are at the top. We'll have two at the bottom with our BL Touch. Oh, I'm like, why is that not working? Because this still needs to be taken off and put on the other bracket. Do the other bracket. Oh yeah. They definitely could have routed some things a little bit better. Like this right here is 100% threaded into the plastic, which is fine if you use an appropriate material. They had used PET G, which we all kind of know is not the best for heat resistance. So it had started to um, it had started to come undone. Not come undone, but oh crap. Not just it had started to warp. That's the word I wanted to use. It had started to warp. Ooh, yeah. Want to. I'm gonna want to go with some shorter so that we're not like a centimeter into the case. That would be bad. .25 millimeter. Okay, we'll pull the 25 millimeters. Let's go with 18s. Grab black. Ah. So I made the bar a little bit thinner as well because I thought it was just thick in all the wrong places. That makes sense. Yeah, the PET G had warped. Yeah, that's better because I know at least on this side there's a ton of wires shoved in that little space, and I don't want a wire being jammed into those if we can help it. And I don't have a good and easy way of get this to stay standing up. I can use tree block. What I'm trying to do right here is validate the Z or the offset for the BL Touch and see if I need to change that mount around somehow. I don't think I do. And the other thing, Waters, is I can't tell if, how can I say this? I can't tell if the printer wiring and stuff like that is stock or not, right? It, I can't tell if that wiring is stock or if it's been messed with. Yeah, that's just too tall or too. What I'm trying to do is get this at a 90 degree to the side here. There we go. Let's use this. It'll probably work out a little bit better. So I need my 1, 2, 3 block to be 90 degrees. So a right angle. Basically, I'm making the um I'm making the, we'll say, build plate, right? We're making a build plate for this. So then I can validate the distance for my um, BL Touch to see if I need to put some spacers in, is what I'm trying to say. It's just very, very difficult. And we're about 5 millimeters, and you're supposed to be 3 millimeters. So I need to take up 2 millimeters and drop this down a little bit further. Um, guess it's washer time, huh? So I need to drop 2 millimeters at a minimum, 2 millimeters, right? It needs to be 3 millimeters about of space for the BL Touch to work appropriately. Now this is not a BL Touch. This is the 3D Touch, but it works on the same thing. All right, that's what I was worried about, was if some wiring had been changed. I mean, BL Touch, they sell BL Touches, so one could assume that even if they put a BL Touch in or a 3D Touch, that it would be a factory option where they would be able to provide the whatchamacallit, the firmware for. And that's where we won't be able to verify until tomorrow when we get everything plugged in and then see, like, is the X going in the right direction? Okay, and it's currently set to minimum. So if minimum's going to the left, which it should be, then that means that um, the well, whatchamacallit, um, um, the end stop needs to be fixed or changed to a maximum instead of a minimum. And I don't know. Like I said, because it's Marlin, we don't have ad break. I'm gonna wind up making these longer. I think these are 8 mil. I'm gonna actually grab, what do I got? 8 mil. Ah, grab. Now, what's the best spacer to use? We need at least 2 mil. If we do one of my favorite spacers, we thanks, Evil Diesel. Um, I don't know if it kicks in before, but this is 2.5 millimeters thick, and this is what I tend to do is use. You can use either washers, or you can use. In this case, I'm going to use a hex nut, basically as a spacer, right? So all you're going to do is just take your hex nut, screw it all the way down on your um, thingamabobber, and that becomes your spacer. That'll drop it from 5 millimeters down to 2.5. So it'll be within that 3 millimeter gap, which means it's long enough that it can trigger, and then you can set your Z offset. Um, I was doing this before on my doing something similar with the Penda probe on the Ender 3, and you get it close to the end of the bed, and I would use a 3 millimeter wrench. Boom, there's your 3 millimeter right there. You're good. Get you close enough in the ballpark that you're not going to run into issues. Now, because we're adding spacers and I'm going through a threaded material at the moment, I also went ahead and grabbed some larger screws. So that I can screw way into or even all the way through this plastic. Easy on myself and get this plugged in before I get it all the way down in there. And because there's no moving parts behind here, if these stick up past, as long as they're not like a centimeter outside, we'll be good. Yeah, okay, so 16s would have worked. That's all good. Again, you want to snug these down, but don't crank for the fences, because if you do, you'll strip the plastic, as we're just screwing into plastic. And then you are going to have to try and get in there with longer screws and some nuts to try and get that down. But there you have it. We've got our 2 cables that will connect to the back end. Everything's in there nice and neat. Our tool head's done up. We can put in our fan duct. I'm going to leave it off though, so I can start taking measurements and try and CAD this up. Wish me luck. Where the hell did these come from? You see? Oh. Did I literally pull them? I don't know. I don't know. Okay. I'll bring this back. So funny enough, I looked at what was on that USB stick thinking, hey, hopefully, maybe, wait a minute, somehow, is there something on this FebTop branded SanDisk hard drive, right? And the answer is there's 2 Benchy files. No manual, there's no manual, there's no config file that I can find. So we're still going to be shooting in the dark. I did get a whole set of the black anodized 4mm screws that I'll bring as well. That way we'll have that. I think that ABS mount is going to work perfect. I don't think we need to go back and reprint this in nylon. It's close, but it's not that close. And with a good working fan, it should be fine. We now have a good working fan there. So these are M3 by 8s. Oh wait, use the M3 by 8s for the fan shrouds. So stop trying to take those and put them up. That goes there, that'll go there, so I can put that back over there. I think my brain is now working. Do you want the Panchroma box back? I don't think you do. But I do think that's kind of all for now. Definitely thanks for coming in, Nick, and Waters and stuff. So would it make sense to put inserts in there down the road? Inserts into what? So, well, into the BL Touch mount? It's thin. It's thin because it's got to have a cutout so that it can slide over the top of the screws that are holding the heat sink in, and the screw that holds the hot end in. So yeah, it should snap into place tomorrow with no hiccups. Like I said, the biggest thing is the fan. I'm going to take some dimensions off this and try and at least get the mount portion into CAD. And then I'm going to have to figure out, do I kind of do this slope thing? I'd really like to get something that maybe does a C around it, but then we have to be careful we're not getting in the way of this. This kind of makes it some stupid thing. I don't know. We'll see. We'll see. Yeah. There you go, Diesel. Yeah, it's all Water's fault. If it doesn't fit, it's Water's fault. It had nothing to do with me having this at the house for a week and a half. And that's true. I mean, we don't know. We have not applied power to this at all. Like I said, the wiring was a mess. I did see where in the terminal blocks there was 24-volt and ground connected together via the terminal blocks. They were definitely using mixing of colors in a inappropriate way. We've now got things labeled as best as I can. We've got the wiring cleaned up. It makes sense. I validated the everything was working in the case with 3 dummy thermistors. I have now validated that the built tool head is functional and heats up to 200C. So that's done. Um yeah, I mean we validated everything we can. Now we just need to hang it back on the printer, cable up the actual cables, and start testing to see, do the motors work? Are we skipping any steps, which could just be that the belts are loose? It uses 15 millimeter belts. So we're going to have to order those at some point if it needs belts. If the belts are crap and we can't stretch or we can't tension them or whatever, we might have to go and get new belts. Um, I know they had successfully gotten prints on the machines in the past. Exactly. But also looking at the machine, the past was a while ago and it's been sitting in storage. So that's my thing. It's one thing if we just need to turn on or off or change min to max on end stops that we can do in the console. If things are wildly off, we don't have Marlin to configure it. I don't know. It's custom Marlin with a custom uh, screen because once again, it's set up to be able to do either a an FDM toolhead or a laser toolhead. Did it get moved in the wire? Well, it was moved, Nick, because it was donated to Ecovate 3D. The wiring was borked. The all of the wiring, right? The wires into the controller board for power. Um, Even now, the wires going into the like chamber heater controller are bare wire. They're bare wire because I don't have a small enough fork connector or ring terminal to go on those screws. I have to try and figure them out. So right now, some of that is still bare wire, but it's the things that I could not do. Everything else got a ferrule, I started doing crimp fork connectors, and then I when I ordered terminal blocks thinking I was getting the right ones, they were too big. So I decided to go Wagos. So I was cutting fork connectors off and running Wago connectors, and ferrule on those for the stuff that wasn't a 16 gauge or 14 gauge cable, um, whatever gauge it was. Um, so the 110 coming in through the power outlet are just bare wire into Wagos, but that's safe for a Wago. That's allowed wiring in a Wago. But on the smaller stuff, I was putting ferrules on just because I like the look and the feel of it. So like I said, right now it's got Marlin. We need to verify the Marlin settings. I just sat here and walked through and wrote all of them down. So I've got all of them written down now. I wrote down all of the wiring. So aviation cable E, um, pin 1, pin 2, pin 3 went to this on the mother or on the MCU. So the other thing for that is oh well, the MKS may be 1B, 1A or whatever. The motherboard manufacturers or control board manufacturers don't always do the stepper motor, 1A, 1B, 2A, or whatever in the same order. So at least if you know how it was on the old one, you can repin things for the new one. If you know that the fan is negative positive on one, but on the other board it's positive negative, you depin it and you repin, you just swap the pins and you're good. But you don't know that if you're not looking at the two diagrams side to side or have a wire mapping, which is what we now have because I created it. I'd love to do a fancy diagram, but that's down the road. I'm not becoming support for an Optima P1, even though you can still buy the damn thing. So the company website is defunct, but you can still buy the darn things. I don't know if you're buying them used or what, but I've seen some that are used that you can buy, and there's distributors in the US that may still have some. It's it was KBW, was it? Yeah, it was West 3D KB 3D merge. Yeah, that was hilarious. Because I'm like, great. I had, it makes it easier because I'm affiliate with both. Um, are they normal stepper motors? Okay, there's that's the E stepper motor, normal NEMA 17. X is a NEMA 17. Y is dual NEMA 17s, but I don't know if they're standard or like extended version. I haven't really looked. I mean, I've looked at them, but I haven't gone in to try and measure them. Z is NEMA 23s running off of external, like chonky CNC style drivers. They're running at 4.8 amps and some insane micro stepping. The drivers, oh dear God. One, they're all configured as dumb mode, right? Which is just dumb. But it's a 2208 for the X, 2209 for the Y. Z, of course, is the external steppers, which I still haven't figured out what model they are. And then the extruder motor looks to be a DRV, was it 8825? Makes no damn sense. Like every single stepper stick on the damn motherboard is different. So that it was blowing my mind, and that's why. So here's a thought. Um, this is a future thought. Um, Waters. So the Trident 350 that is sitting on the floor behind me, that we have done we did a Cybor all-wheel drive CNC upgrade too. So all of the gantry parts went from printed to CNC machined. 9mm belts. It's now rocking a SLM printed takeoff tool head with a tube hot end, dual 3628 fans, and an FXD extruder. The previous, it had a Filomatrix on it with a CAN bus, so it's going to stay CAN bus. I have an EBB 42 board that I'm going to mount on the back side of the Bondtech extruder for the FDX extruder. The printer was from DFH, and because it was from DFH, and even though it was doing CAN bus, because it came as a CAN bus kit, it means that it was running a Manta M5P. So I have a Manta M8P that just showed up with a beacon probe because the Cartographer V3 won't fit on the SLM mount. So I'm going, as soon as I'm done with all of this stuff, we're going to put the Manta M8P in. We'll take the CB1 and move it over, and then that will leave us a Manta M5P. Now I think I've got another CB1 module sitting around that we could potentially, I don't know, throw on a very large printer that uses a motherboard that only uses 5 drivers. And by the way, I will definitely be redoing this fan duct because that happened to the fan duct as it was when I heated this up to 200C. Probably because there was no cooling fan going. So it's already deformed. Welcome on in, Raiders. Welcome on in, Free Heathen. How are you doing, nerd? You have missed all of the fun. We have been all over the place. Everything is different. Yeah, it's a bespoke Franken printer. That is for sure. Oh, Nick. I will get this printer working. I guarantee this printer will work one way or the other. Free Heathen, welcome on in. Thank you for the raid, my friend. I will stand up. I will go full screen just for you. Welcome on in, Raiders. Welcome on into the Dragon Den. My name's Digital Dragon, otherwise known as Luke, and I am a 3D printing variety streamer here on Twitch. What does that mean? Well, it means we do everything from printer unboxings like our X1 Carbons and K1C, pull up printer builds like the Vorons, the LH Stinger. We take part in beta test programs and do a lot of prototyping work. As you can see, we've got plenty of box turtles around. I'm part of the beta test team for that. I'm also beta testing hot ends and various other things. What I've been working on tonight and over the last couple of nights has been rewiring the control box for an Optimus P1 Pro. What is that, you may say? Well, this is a Swedish-made Core XY printer. No, it's not Core XY. It's still a Cartesian printer, but it's 600 by 600 by 1000 build volume. This thing is massive, and the control box, we just took it off the printer and brought it home. So I have been rewiring and making safe this entire control box here, so that we can go and plug this back in and verify whether the printer is still functioning, because it was brought in a sad state. Some of the drivers, as in the standalone CNC style drivers, were not even mounted up. The tool head was a mess. We got that put back together tonight. This is rocking a Volcano We did a little bit of upgrade. It's now titanium heat break, nickel plated copper heat block, a 6 millimeter Fadis all metal hot end. Yeah, we need to redo the fan duct. I had to reprint the uh, 3D touch mount because it was PETG and warped. This fan duct, I have no idea. I'm believing it may have now been PLA because it melted. Um, just sitting up against the silicone sock of the volcano. So yeah, that's kind of what we've been working on. We brought the Key Tech up here, Evil Diesel. We brought the Key Tech X Pro up here when I realized I was going to have to CAD this up and didn't want to do that on stream. And yeah, the two thermocouples that I ordered off of eBay and got in work. However, they're 3 millimeter thermocouples, and the Key Tech X Pro, or at least his current heat blocks, require 4 millimeters. So hopefully the two that I ordered off AliExpress that work with the Flash Forge are 4 millimeters. If not, I don't know. I do not know. We'll have to figure that one out. A beefy duet board would be great for that. It doesn't really need it. It is running right now on an 8-bit Marlin board. Believe it or not. And it works. I mean, we've had it up, we've had it running. I took this, plugged these two directly into the control box. So we basically circumvented about, I don't know, 8 foot of cable, and everything came up right and well and worked fine. We heated the hot end up. The BL Touch or 3D Touch seems to be working. The only thing I need to do is do a new fan duct because my heat break sits down a little bit. Um, Tube is fun to say. Yes, it is. All right, Waters, take it easy. I will see you tomorrow at some point in the afternoon. Um, yeah. So hopefully by Saturday, we'll be back on the Trident and we'll be installing, you know, a beacon probe. And I've got a, why aren't you opening? Open. Manta M8P board. The board that's currently in it is an M5P, which just does not have enough drivers because we went from a standard Trident, which is 3Z, a B, and an A motor, to an all-wheel drive, which adds 2 more motors. So we needed the extra motors or stepper slots to run extra motors. I'm going to take the CB1 off of that other board, slap it right here, and be able to hopefully reconfigure without a whole heck of a lot of drama. Yeah, I say that. Really, I don't want to lose the print history, but I might just say the heck with it and be done with it. If I have another CB1 or a CM4 module sitting around, I'll just swap it out. But that frees up a Manta M5P, which has enough drivers for the Optimus P1, and it would also have a CB1 module on it for the host controller. Bada bing, bada boom. We can now clipperize that thing. What I would probably do is definitely keep the old board, get everything plugged into the new board, and work on getting it up and running. And then if it's good, great. If not, we always have the fallback of putting the other board back in. We just need to make sure that we have the knowledge of the wiring, which is why I did the wire map and why I just went and pulled all of the Marlin configs out. Because if we're going to try and clipperize it, we're going to need that data. But yeah, hey Jedi Spidey. So Jedi Spidey, I chatted with Beverly, and I did get things cleared, and we are going to start doing maker hangouts and maker meetups, hangouts at Echovate 3D one Saturday a month, which is great because it's going to be later in April. Later in April because of Easter. Later in May because of Rocky Mountain Rep Rat Fest. Later in June because of Murph. And then kind of, I don't know, second or third week in July. And what we're going to do is we're going to do I say morning, it's afternoon. It's noon to 3 because they don't open till noon. So we'll do like noon to 3 1 week or 1 month. The next month it'll be 4 to 7, which is basically 4 p.m. to close. That way we can get people at different times, you know, if they've got kids who are doing sports and whatnot, you know. So if you're out there on the Evocate Discord, I'm going to try and get a work with Waters to get events set up for those. We're going to try and get some flyers that I can post out on the socials and things. But yeah, that's kind of what I'm going to try and throw those in there, which means on stream days, we're going to have to figure something out. Either I'll go down there for a few hours, come back here and stream later at night, or we'll switch to stream days or something like that. Cool. So with that being said, folks, I am at a stopping point. I have nothing else I can work on because I am not going to try and clear everything off the desk so I can bring the beast up here and start working on that because we have to rewire. And I'm not going to do a brain swap this late at night on a printer. That could lead to bad things. So with that said, thank you, everybody. I'm going to go take some allergy meds, so hopefully I can breathe out of one side of my sinuses tonight and get some sleep. And I will see you all next time, Thursday. Eel Diesel, if you want. Oh wait, tomorrow's Wednesday. You'll be busy. I was going to say, you can come on down to Echovate, but you'll be busy. We'll figure out another time to go down there and see the big printer. And maybe I'll try and get some footage of the big printer while I'm down there. But thank you all. I appreciate you all coming out and being here tonight. Thank you for the raid, Free Heathen. Hope you can get some food and get some rest. And everybody, I will see you guys on Thursday. I guess I should figure out where we're going to raid into. Like about ready to cut and run. Let's see who's up and running. Creatix Brit. Oh, birthday stream done. We gotta go say happy birthday to Create. Okay, folks. Thanks much for being here. I'm getting a raid ready to go over to Creatix Brit. I will see you guys on Thursday. Stay safe. Enjoy this nice weather we're having. And I will see you guys in a couple of days. Bye now. And for those of you that are watching this later on YouTube, thank you so much for staying all the way to the end. If you like the content that you're seeing and the cool, weird projects that we work on, please hit the like and subscribe down below. Be sure to check that bell to make sure that you get notified of new video content. YouTube's going to be suggesting a video over. Thanks now. Great day.